Now we're going to look at a concept called electric current. So let's think way back. Let's connect the dots here from our last unit. What do we know about charged particles? So I've got some here. We have some positive charged particles and we have negative charged particles. Those are some things we know about charged particles. And again, go back and take a look at page 212 in your book. It will show us which charged particles move. What do we know about the interaction of charged particles? So when we have a positive and a positive, are they going to repel or attract? When we have a positive and negative, are they going to attract or repel? And a negative charge particle, what's going to happen? So let's review. Negative, negative, same is going to repel. Opposite, negative, positive are going to attract. And positive, positive, same are going to repel. What do we know about the two ends of a battery? You investigated this already. We have a positive end to our battery, and we have a negative flat end to our battery. So how will charges interact with the two ends of a battery? Well, let's think about it for a second, right? So we've got a charged particle up here. We've got a positive charge and a negative charge. So with our negative charge, which one is going to attract? We're going to have, which one is going to repel? Think about that. So in this case, I'm going to go with our negatives. We've got a positive, so we are going to attract our negatives, because if you went back and looked at your page 212 notes, you know that the negative charge particles are the ones that move or transfer. So these negatively charged particles are going to attract our positively charged end of our battery. So now let's look at this concept of electric current. This is connecting a lot of pieces. We have our battery, right? Has a positive and a negative end. We've got positives, sames are going to repel. Negative and positive are opposites, so they are going to attract. We've got negatives that are the same, so they are going to repel each other. So as we watch this video, I want you guys to think about which direction is that positive and negative battery going to be going. So let's watch this for just a second. So right now, we see that we have our negative. So remember back to page 212, negative particles charged are the ones that move or conduct within our conductor. So we've got our electric device, our light bulb up here. We've got our electric conductors. We've got our positive battery end and our negative battery end. So if we go back and watch that movement, we're going to watch that these negatively charged particles are going to move through the conductor and be attracted to the positive end of our battery, and they are going to be repelled out of the negative end of our battery. So let's watch that again. They are being attracted to the positive end. What's going to happen when we flip the side of that battery? So in a minute, I'm going to flip to the other side. What's going to happen at this case? Here we go. So we flipped it. Watch the movement. Those change direction. The movement of our negative particles change direction. We are now moving those particles through our electric device, down through our electric conductor. Our negatively charged particles are being attracted to the positive end of our battery, and they are being repelled through the negative end of our battery. So we're going to flip it one more time and watch what happens to the movement. The movement of those batteries change again. This is why sometimes our electric devices don't work when our batteries are in the wrong direction. So what's happening? When electrical charges pass through an electric device, we are transferring that energy. So as we are using this, we are transferring energy from this battery up into the light bulb. So this idea of transferred is really important as we continue to move forward in this simple circuits unit. So we are transferring the energy from the battery to the light bulb. The movement, so this movement that we're watching of those negatively charged particles moving through our conductor, I'm going to keep this playing in the background. That movement of electrical charges is called our electrical current. That is our electrical current. We are creating a current of negatively charged particles moving from our electric energy source through our electric conductors to our electric device, where we are transferring some of that energy, and then back through our conductor and into our battery.